practicing performance optimization is like so critical and so important. And as a data scientist, I don't care a flip about it, at least for right now. For what we're going to talk about today, we are going fast and loose. We are just trying to like look at some data and get some insight quick. And we are not going to worry about optimization right now, because then I'm going to hire a backend engineer like Nadia to come in and clean up my code later. So just want to give you kind of a framework for what we're going to do today. I'm pasting into the chat channel here a link to the code if you want to follow along with what I'm doing. This bit.ly link just going to take you to my GitHub, to the page that we're, the repo that I'm going to be pulling files from. And so I'm going to start sharing my screen, and I'm just going to go to this page itself. So I've got, I hope you can see my screen. I'm just going to come over here and paste in that bit.ly link, and it's going to take me to my GitHub page. I'm going to go ahead and clone this onto my computer so that we can work on this together. So I'm just going to clone, copy this link, and git clone this repo. So we have a couple of files in here. Let's get into DC Meetup, and let's look in here. So there's some files in here. We're going to go through what each of these does. But as a data scientist, one of the tools that we use most frequently is called Jupyter Notebook. It used to be called IPython Notebook. And so what I'm going to do is start out by looking at this data overview.ipynv file. You can also click on it directly in GitHub. GitHub has a notebook viewer, and it just won't execute code. And so I'm going to be executing code live. If you want to follow along with me, we're just going to run Jupyter Notebook from command line if you've got that installed on your computer. And I'm going to go into the data overview.ipy notebook. And here we are. So you can see kind of the server that's running over here and my code that's going on over here. And so what we're going to do today is just going to grab a quick data set and visualize it, like play around with it really quickly. But then we're going to turn it into a web app. And so we're going to build a really quick web app to identify nearby hospitals here in the DC area. Again, you've got a link to my code, and this DC ambulance is just zooming right on by. So today we're going to grab some data. We're going to explore it the old way using a package called Pandas. We're going to build a local app using this new tool, fancy new tool, the new hotness called Streamlit. I am in no way associated with Streamlit. I just like stumbled across it a couple of months ago and am in love with it. So I wanted to share that with you guys today. And then finally, we're going to deploy that web app to the web, like there's a live website that we're going to create using Heroku. So a couple of prerequisites here so that we're all on the same page. I'm going to expect that you guys know a little bit of Python, understand a little bit about Jupyter, right? We're going to do a little bit of Pandas. If you're not familiar with it, Pandas is just like Microsoft Excel, but for Python. And so it's just like a table viewer, basically. We're going to do a little bit of Git here. And then if you're going to follow along entirely, I assume that you have a Heroku account and the Heroku command line interface pre-installed. Cool. So the data set that I've got for us today comes directly from the DC Open Data Portal, and it's just a list of the primary care centers here in DC. So this is just some data. We can explore this a little bit, but specifically what I've done is there's this download button. You can download this full data set as a spreadsheet, and that is what we have right in here. So this whole thing as a spreadsheet, we're just going to bring this into Python, and .head looks at the first 10 rows. So shift return runs this cell, it downloads it, and this is what some of this data looks like. So I see the 5 rows here. I've got some of these names of these hospitals and maybe where they are and what their zip code is and what their ward is and blah, blah, blah. I don't care about this data specifically, but like this is what this looks like, right? And so I want to turn this into something that maybe we can get some insight out of. So I don't know, let's get a count of hospitals by ward and maybe show that as a quick bar chart. So I can grab just that column from the data frame, and there's this command called value counts. I run this really quickly, and it shows me that ward 1 has the most hospitals, followed by ward 5, ward 8, all the way down here, ward 3 only has 1 hospital in it. So if I were interested in getting to a hospital quickly and I lived in ward 3, that probably wouldn't be such a great idea. This comes from the value counts command. So if I just pass that into bar plot, matplotlib inline just shows this, well, inline. It's a Jupyter Magic command. And I can just see a quick little bar chart of this showing exactly the same thing that I had done previously. And if I wanted to maybe like map this, there's a million ways to map things in Python. But like a really quick way is to show those X and Y coordinates. We don't have any fancy mapping tools. I might have to bring in like, Open Maps or Google Maps or something to actually show some map data. I couldn't be bothered to do that. And so we have here kind of a distribution of our hospitals across DC, but this is kind of ugly. Jupyter Notebooks are great for data scientists for handing off to people who are technical and who know how to run this, but like they're not great for people who aren't technical. So if I wanted to share this with my aunt, who is definitely going to get coronavirus, I want her to be able to see something that's like a little bit easier to manage. So from here, we're going to just basically do all of this again in our web app. So I'm going to go back over to my GitHub repository, and we see that I've got this file here called app.py. This whole thing, I've got 37 lines of code here. This whole thing is my web app, but we're going to build this line by line. So I might just come over to my terminal. I'm going to just go back into this. So code, we're here in DC Meetup, and I might just open or subl, new app.py. So I've got a plain empty file here. Let's just start building this, this web app. So I'm going to basically go line by line through this and talk about the things that we need. So we've got a couple of imports up here. We're going to import Pandas as PD and Streamlit as ST. It's just their naming conventions. We're going to leave it as is. And I'm just going to bring these first two lines here, st.title and st.subheader. Okay. I've got these two lines in here. I'm going to come over to my terminal, and I'm just going to issue the command Streamlit. Let me make this a little bit bigger for you guys. Streamlit run new app.py. That's all there is to it. That's running a server, and it pops up, and boom, I've got a website that's up and running, right? It's got hospital stat and like my map of DC area, just the same things that I have over here. Now this is running on my local host port 8501. So it's not running anywhere where my aunt can see it, but we've got a good start here. And so let's add some more to this. All right, I'm gonna go back over here. Let's pull this data in and take a look at this data. So this function here is called fetch data, and it's gonna go through and do the same exact thing we did earlier. It's just downloading that, that file. I'm doing a rename here just to make some stuff that we do in the future a little bit easier. So remember, previously our columns had these really like funky names in here, like primary care PT name and PT address and like all this kind of stuff. Our X and Y columns are have our lat and long stored in there. So I'm just doing some quick renames here so that we name our X column longitude or lon, our Y column lat, and then just renaming this ward just to be ward. So it's easier to work with in the future. I return that data frame, and then I'm loading that data in. So I'm just going to copy all of this and paste it over here. Now this line up at the top is really kind of interesting. Streamlit.cache goes in and it stores a copy of this data because this is a network call, right? I'm going to the internet, I'm downloading this data every time. Whenever I reload this data, or there's 80 people on this call right now, if you all went to my website, I wouldn't want to download that data 80 different times. So this cache stores that data on my local server so that it's not making that network request every time. And we see it doesn't take any arguments in here. And so there's no way that the result from this object can change, or at least that's the kind of agreement that we, that's the contract that we agree to when we load in this st.cache. So I've got my data, I've pulled it in. I don't know, I'm just gonna write data here. And we know in Python, just referencing an object doesn't really do anything, but I think Streamlit's going to show me this data frame. So I'm gonna save that data, come back to my web app, and check it out. It already says source file changed. So do we wanna rerun? Sure, I'll go ahead and rerun it. And it fetched that data, and now it's showing me this information. Again, this is just a web app that I can deploy and have anybody use. And so I've got my everything down here. I could explore this data. It's a little bit interactive. I could sort by certain things. So it's a pretty cool, it's like already showing me data in like a Microsoft Excel or Google Sheets type format. But let's take this a step farther and let's put in those, that map and that count of what we had before. So I'm gonna just copy and paste this data in, or these lines of code in. I'm gonna save it and come back over to my, my app. I'm gonna rerun it, and it went ahead and downloaded all that data. This was just created with st.map. It's an incredibly simple call that created this map of all my hospitals in the area. And I can zoom in and I can zoom out. And I bet there's more cool stuff I could do with this if I wanted to. This is a very simple demo. Remember, fast and loose. Could scroll down a little bit and I see those hospital counts by ward. So again, my ward 1 has the most hospitals, where ward 3 has the fewest hospitals. And these overlays are all just built in. This was created using just st.barchart. And finally here, I again have that raw hospital data. I could go through and just have this as a resource if I want. So the very last thing that we're going to do now is we have this really cool thing, but it's just running locally. How do I get this up in the cloud? And to get this on Heroku, if you're unfamiliar with Heroku, Heroku is a just hosting service. And the best thing about it is it's free. And so, or at least to begin with, it's free. And so what I'm gonna do is I'm gonna come over here. I'm gonna kill my Jupyter Notebook server. And I've got a few files here that are gonna help me out with my Heroku deployment. I've got my app.py, that was the original one that we had. I've got setup.sh and this proc file. I'm gonna take a look at proc file real quick. This tells Heroku what I'm doing. So it says I've got a web app, and here's what I need to do. I need to run setup.shell, and then run the same thing that we did before, streamlit run app.py. And if we take a look at setup.shell, we'll see why. It really wants, the first time you run Streamlit, it wants you to register an email address. We don't really care about that. So we're just putting a bogus email in here and writing it to this credentials file so it doesn't bug us. On Heroku, we won't be able to interact with it. So we have to make sure that we can kind of pre-program what we need to do. So in order to do this, I've got instructions in the README over here. So if you are following along, to deploy to Heroku, I'm just going to run git init if you're not already in a Git repository. We are in a Git repository right now. So I can jump straight to the second line, Heroku create. So I'm gonna say Heroku create, and then you can give it whatever name you want, so long as it's new and unique. Remember, this is gonna be the name of your website. So I might call this DC Python Streamlit Demo. And now that I've created this, you can't go in and steal that name. You have to go in and pick your own. It says it's created that. Our final step just says git push Heroku master. So it added that Heroku as a remote, and it's gonna go through and deploy this. Now this is gonna take a second, and I'm going to leave my screen sharing on so you can kind of see what's going on. This will probably take about 2 minutes to do. So I wanna go ahead and open up the floor for questions while this is running in the background. And then when it's ready, I'll stop the questions so that we can take a look at our brand new shiny web app that's gonna keep my aunt and your aunt safe. So opening the floor for questions now.
Awesome. We'll go ahead and start with anyone who might have raised hands.
So Nick's saying, how is, oh, sorry, did anyone with a raised hand want to go first?
Oh, no, that's
sorry,
okay,
Lauren.
go ahead. You're good, looks like there aren't any, so go for it.
Okay, great. So I'm gonna, thanks Melissa for your comment. I'm gonna jump to Nick S. How's the scalability? It's like not great so far from what I can tell. I've only been, this whole app, from what I understand, only came out in November. So it's very new in terms of development for it. And I have no idea what's going on under the hood. I've only used it for some smaller sized data sets. And in that sense, it works great. If you're familiar with Heroku, you know that the computer that they give you for free is not very powerful at all. I mean, I think it has like 100 megabytes of allocated memory and only 500 megabytes of allocated space. And so some larger data sets, like we were working with 311 calls from the DC data set. There's like tens of thousands of them. That slowed it down a little bit. But we'll see in this example that it's going to be pretty responsive for this small data set. And you know, this is just a tool for quick iterating of data. This is by no means something that you should ever deploy to production or you know, have large scale. Let's see, Adam asks, could you say more about Streamlit? No, not really. I mean, I don't know much about it, right? There's a website that you could go check out. So I'm just gonna Google Streamlit, and you can check out their, so it's just streamlit.io. So you can check out their documentation, their tools. They've got some really great, like getting started, but you can see here, like, they've got a video of them building this website. It looks like they're doing some image classification or some object detection in real time using Streamlit. Let's see, James says, any way to test before Heroku deploy to make sure Heroku doesn't barf? So we did test a little bit using just like the local deployment. As far as testing Heroku's configuration, I'm not the best person to talk to. You might want to go and talk to Nadia or someone who's like a better back-end engineer about something like that. When I was doing this myself, like Heroku did barf on me because I forgot to rename one of the files. So Heroku does have a very useful tool where you can run Heroku Logs --tail, which is going to basically show me what's been going on my server. The --tail means keep it running in real time, and as new logs come in at the bottom, it's going to show me that information. So it looks like things are maybe running right now. And while I've got my screen sharing up, let's actually go and check this out. So my URL, it says, was DC Python Streamlit.demo.Heroku app. So let me copy this and paste this into our chat window so that you can check it out if you want to. Don't everyone hit it too hard because we're all using the same Heroku resources right now, but B, I'm pulling it up here. This is 100% live on Heroku, the code that we just wrote and deployed. And so to the question of scalability, you saw it was a little slow getting pulled up, but like not so bad. And there's a lot of interactive elements of Streamlit that I did not incorporate here. You've got sliders, checkboxes. You can kind of mask data or do whatever you want. Each of those things is going to make calls to either the network if you don't have it cached, or your local things that are cached. So I'm going to jump to a couple of these other questions. Let's see. Troy, is this going to connect to the internet immediately, or do you have to forward the traffic? Well, as you can see, I didn't do any other configuration. Heroku is hosting this entirely for me, and they give me a subdomain at their herokuapp.com. You could also set up your own forwarding if you have a domain that you want to point. Heroku's totally okay with that. They just, they give you this for free. Let's see, does Heroku automatically spin up new instances? So if you're unfamiliar with Heroku, it will spin up this instance for me right now. One of the ways it saves money is that when you're not using it, it goes to sleep. And so if we all stop referencing my website right now, and one of you goes back, wants to check this out a week later, the first time you try to access this site, it's going to take about maybe 15 to 20 seconds before you get a response from the server. That's Heroku spinning up a server on the fly, reloading in the last state of my app, and then serving it to you. But as soon as that server is like woken up or spun up, future responses are going to be very, very quick. Let's see, Heroku can and will delete files you write to storage. That's a great call out. Always use cloud storage if you're trying to save things long term. So, you know, S3 or Google Cloud Storage for stuff like that. And let's see, any other questions? Could we spin this up on AWS? Absolutely. Spinning this up on an EC2 is just going to be like your normal deploy processes. AWS just, I'm not as familiar with kind of quick ways to deploy to AWS, so you could easily, I guess, do the same thing and kind of have a daemon run in the background, making sure that your server is always running using, Unicorn or Apache or some other server like those. I have not messed around with this using API Gateway and Lambda, but I believe wholeheartedly that that would be possible. One problem with serving data like this is that if you're doing this through Lambdas, there's not going to be a caching function, right? API Gateway is going to spin up a new instance for every request that comes in. And so if your app involves pulling live data from the internet, that's not going to be as effective. But if you have that data saved just as a CSV file that's deployed to your Lambda, that would be a great instance here of using API Gateway and Lambda in conjunction.